This video covers Chapter 8, entitled Mobile Devices. Some objectives from Chapter 8 are to describe mobile devices, compare and contrast Android versus the iOS, explain how to configure network and email connectivity on mobile devices, and identify securing and troubleshooting methods for mobile devices. A mobile device is categorized by any device that's handheld, light, and typically uses a touchscreen for input, although it does not have to. Mobile devices will typically have integrated displays and keyboards. Some examples are Android devices such as the Samsung Galaxy, the Galaxy tablet, Nexus smartphone, Apple iPad, and Apple's iPhone. Most of these mobile devices use an operating system and run apps or applications. And these applications can range from a variety of things, from entertainment like watching movies to business applications like word processing. Many mobile devices contain non-field serviceable parts, meaning that you can't really do a whole lot to fix these. There's not a whole lot of things that you can do to replace other than the battery, memory card, or the SIM card. If you want to be daring, sometimes you can try to replace the monitors and keyboards and things on them, but without specialized tools and without a little bit of training, you're probably not going to be able to replace these things. Most mobile devices also have non-upgradable hardware. Most mobile devices come directly from the manufacturer with all the capabilities that they're going to have. Sometimes you can upgrade batteries to bigger batteries for better battery life, or you can upgrade memory cards for more internal storage, but you're not going to be adding RAM or replacing the CPU or motherboards or things on, let's say, an Apple iPhone. As I said, most mobile devices use a touchscreen, and there's two types of touchscreens that are out there. There's a capacitive and there's a resistive. The capacitive consists of a glass screen coated with a conductor. What this does is this senses an interruption in the electrical field of the screen, and it can calculate the location of where you touched based upon that break of the electrical field. The resistive is based upon pressure. Depending on the pressure of where you touch the screen, that's how it calculates where it's at. Both of these technologies are relatively good and rock solid right now, but it still may come into play as far as choosing which type of device you want to select. Most mobile devices are going to use solid-state hard drives or SSDs. Solid-state hard drives offer significant advantages over regular hard drives. First, there are no moving parts. Has better power efficiency, which is huge with mobile devices because they almost strictly run on battery power. Very reliable, lightweight and compact, very high performance. Solid-state hard drives compared to regular hard drives are no comparison as far as speeds. Solid-state hard drives blow away regular hard drives in speed tests all the time. And there's no noise, they're very quiet because of the no moving parts. An example of a solid-state hard drive would be like an SD card. An SD card that's used for a phone or for a camera or something like that. That's sort of like a solid-state hard drive on a much smaller scale. The main two operating systems that are discussed in the Cisco curriculum for mobile devices are the Android, which was developed by Google in 2008. It's open source, which means the public can change, copy, or redistribute the code without paying royalty fees to Google. And there's also the iOS, which was released by Apple in 2007. This is closed source, which means the source code is not released to the public. There's a couple screenshots down below that are pretty small that show you what the basic look of the Android and the iOS operating systems look like. We could sit here for days and debate which one is better, but the bottom line is, as an IT person, you're gonna have to be familiar with both because they're very saturated out in the market, both the both the Android operating system and the iOS. This slide here shows some common features of the home screen for the Android. Almost all home screens for the Android operating system have some type of Google search integrated, since this is from Google. We have the navigation icons. They always have a back button and a home button, and then they usually have two other buttons that may depend on which type of device that you're using. The iOS operating system works much the same way that the Android interface does. There's home screens which are used to organize your apps, and apps can be launched just by touching on them. The iOS does not have navigation icons, widgets, or app shortcuts like the Android does. You're going to notice it doesn't have a back button either. It has the home button, which performs many of the same functions as the Android navigation buttons. It wakes the device up, it returns to the home screen, it's used to put the device to sleep. It's the one button that gives you most functionality with the Apple iOS. In all the Apple iOSs, you'll see the notification center. This displays all of the alerts from the apps in one location. We have apps, which are applications that have been installed onto the iOS devices. Many of these are going to come from the Apple Store. We have the multitasking bar. This allows the iOS to have multiple apps run at the same time. And you can have folders on your different screens so that you can organize your different apps and documents and things into folders so they're more easily accessible and more easily organized. Mobile devices are going to use some type of wireless data network. Most often this is going to be some type of cell phone network, or it could also be a Wi-Fi network. First we'll talk about cellular communications. You probably heard of the terms 3G and 4G. Well, it all started with 1G. This was the first generation that phones primarily used. It was mainly analog, and there wasn't a whole lot of data sent over it. Currently we're in the 4G, which is the fourth generation. There's different standards out there, such as the Mobile WiMAX and LTE. You've probably heard the commercials for Verizon's LTE. Most of the mobile carriers have adopted the LTE standard. With 4G, we have greater speeds, which allow better streaming of video, faster download speeds, and just a much better user experience. Bluetooth is a technology usually used to tether or connect to another device, such as connecting your mobile phone to your car so you can hear your phone's audio through the car's audio system. Bluetooth is a solid, proven technology that's been around for a while and will continue to be around in all new mobile devices. To use Bluetooth, you must pair the two devices together. Usually the pairing process involves turning both devices on, one device searching for the other device while it's discoverable, and authenticating through a PIN. Once this is done, the initial pairing is completed and you should not have to do it the next time. Many users like to get email on their mobile devices. You should be familiar with how to set up an email account on a mobile device. Some things that you'll need are the display name, email address, the protocol being used, usernames and passwords. Most protocols are either going to be POP3 or IMAP for the delivery, SMTP for the transfer, and in conjunction with the MIME protocol. The main difference between POP3 and IMAP is that POP3 retrieves the email from the remote server but does not leave a copy of the email on the server. It actually downloads it to the device. So if you have multiple devices that you check email from, your email may be on one device but not the next, because it does not leave that copy on the central server. Where IMAP does leave it on the central server, so no matter which type of device you're connecting from, if you have a cell phone and a laptop, you'll see all the same messages because you're connecting to that central server and getting that original email from the server. To configure email through Android, typically it's going to be tied to some type of Gmail account, but it also does have other apps that you can use to connect to a corporate account, such as Outlook or an Exchange server. The iOS uses the iOS Setup Assistant, and this is tied to an Apple ID and an iCloud email account. You may have heard the term or used the term data synchronization or synchronizing your data between your mobile devices. This is just the exchange of data between two or more devices, trying to maintain consistency between those two devices. Some things that can be synchronized are your contacts, your email, music, and also videos. What this means is from device to device, you're going to have consistent content. So if I'm looking at my cell phone and my laptop, all the music's going to be the same between those two, or all my emails are going to be the same, or all my contacts are going to be the same, because they have synced up and they're synchronized. If you want automatic synchronization to take place for your data on an iOS device, this requires installation of iTunes. iTunes is a media player application, but it also does other things for the iOS software, such as upgrading and activating. Synchronization on an Android device doesn't require any special application. You just need to turn it on under the accounts and sync setup of the device. Using passcode locks is one way in which we can secure our mobile devices. There are many different types of passcode locks, and some are more secure than others. Some of these include sliding, such as sliding an icon like an arrow from one position to the next, using face recognition, a pattern, a pin, or a password. Depending on where you use your mobile device, you may have to increase the level of security and change from, say, a sliding unlock pattern to a PIN number or a password. Many mobile devices have cloud-enabled services that go along with them. For example, the iOS gives users 5 gigabytes of storage free on what's known as their iCloud. Android devices have calendar, mail, and contacts automatically backed up on the cloud. Again, what we mean by the cloud is a service that's hosted on the internet and not on your local area network. Some other types of cloud-based services that you may hear about are locator applications, remote lock, and remote wipe. There are antivirus applications available for both the Android and the iOS, although they're typically not loaded by default when you get one of those devices. In my opinion, it's not as crucial to have an antivirus application for these mobile devices as it is a laptop or a desktop computer, but I will let you make that decision yourself. You may have heard about a process known as rooting your Android phone or jailbreaking the iOS. Essentially what this does is it unlocks the system so that a custom operating system can be installed. Note that when you do this, it does void the manufacturer's warranty, and it can possibly open up the device to malicious programs or virus infection. People typically do this when they want complete control over the phone, or they want to be able to develop their own operating system. Just like a normal desktop operating system, mobile operating systems have updates and patches as well. You want to try to keep up on these updates and patches, as they're going to fix security problems, add functionality, or increase performance. Typically, the devices are set to check for the updates automatically, but you can also prompt them to check for the updates if you wish. When troubleshooting mobile devices, one of the first things you want to check for is whether or not the device is under warranty. If it is under warranty, you want to avoid taking it apart, as this can void the warranty. And if it is under warranty, you probably can just replace it for an exchange. The troubleshooting process is still the same for our mobile devices. We have our 6 main steps, which are identifying the problem, establish a theory of probable cause, test the theory to determine the cause, establish a plan of action, verify full system functionality, and always document your findings. Again, with step 1, we want to ask some open and closed-ended questions. Ask the user what they've been experiencing, ask them if they've had the problem before, ask them if the mobile device is able to connect to the internet, and if they've installed any apps from an unapproved source before. Step 2, establish your theory of probable cause. Some of the common causes for mobile devices is the power button is broken, there's excessive dirt in the speaker and microphone, the mobile device has been dropped, the mobile device has been submerged in water, an app has stopped or frozen, the user has forgotten their password, or just needs a reboot. Step 3 is to test those theories that you came up with. You may want to reboot the phone, you may want to pull the battery out, you may want to try to connect and sync it up to your iTunes if you're using iOS, clean the speakers and microphones if you think that is the potential problem. Step 4, establish a plan of action to resolve the problem, implement a solution. You may need to do some further research here at this step. Check out technical websites, the manufacturer's frequently asked documents, consult the device manual, or take a look on the internet in the form of searches and forums. After you believe you've got the device working, that comes to step 5, where you want to verify full system functionality. Make sure that you can send text messages, that you can make a phone call, that it can get connected to the internet, and that the system is working 100%. Step 6 is to always document your findings, discuss the solution with the customer, journal or write down what the problem was, how you fixed it, any components that you used, any websites or tutorials that you used, and the amount of time you spent solving the problem. That is all for Chapter 8. Remember that mobile device hardware has very few field repairable units. Other than replacing the battery or an SD card, there's probably not a whole lot that you can do to replace it. You can't upgrade your RAM or your processor on mobile devices. Mobile devices are often replaced instead of repaired because of this. Mobile devices contain proprietary parts that usually cannot be interchanged. They usually contain some type of touch screen or other type of input device such as slide-out keyboards. We also talked a little bit about SSDs or solid-state hard drives, and many of these are used in mobile devices because of their size. They're very energy efficient and they don't use a whole lot of battery power because of this. It's a good idea to get into a practice of only downloading applications or apps from trusted content sources, such as the Apple Store or Google's Play. This will help you avoid malware and unreliable content. Remember that many mobile devices are going to use some type of wireless connection. Usually it's a cellular type of connection, but it could also be Wi-Fi or Bluetooth. Be familiar with how to set up email accounts. Many mobile users want to have email with them at all times. So if you get a chance, you might want to set up an email account and see if you can get it to sync with your device. When it comes to securing your mobile devices, passcode locks will help with that. Always try to use the most secure method possible. Be familiar with the cloud-based services that come with the Android and iOS devices. Many users rely on this, and you may be called upon to help troubleshoot problems with them. That is all for Chapter 8. Thanks for watching.